Standard 6.7, use the properties of logs to expand and condense logarithmic expressions. Alright, so before we look at our examples, let's make sure we know our properties of logarithms. We have three properties that we're going to be using here. The first one is what we call the product rule. And the product rule says the following. Suppose we have the log of any base, and that log is of some product, m and n. The product rule says we can expand that by taking the sum of each piece of that product. So it's the log base b of m plus the log base b of n. So a product can be split into the sum of two logs. Our second rule is the quotient rule. And the quotient rule says the following. Let's say we have the log of any base of a quotient or a division, m divided by n. A quotient can be split up using the operation of subtraction. So this becomes log base b of m minus log base b of n. And our third rule is the power rule. And the power rule says the following. Let's suppose we have log of any base of m to some power p. This power p can be brought over to the front as a coefficient. So this becomes p times log base b of m. So we have the product rule, the quotient rule, and the power rule. Everything on the left side here is in condensed form, and everything on the right side here is in expanded form. So our first example says, let's expand the following logarithm. And so what we want is we want to take it from condensed form to expanded form. And we are going to ask ourselves, what's happening in the parentheses here? What's happening between this a and this b? And this operation in here is multiplication. And since it's multiplication, we're going to use our product rule. Our product rule says if two things are being multiplied together, here a and b squared are being multiplied together, we can split that up into the sum of two logs. So this gets split up into the sum of two logs. The first one is the log of a, and the second is the log of b squared, because it's a and b squared that are being multiplied together. Now notice that we have an exponent, so we can use the power rule. 2 here, this exponent of 2 is kind of like our p. And so the power rule says we can bring any power over to the front as a coefficient. So this becomes log base 2 of a plus 2 log base 2 of b. And this is our final answer in expanded form. Our second example is log base a of x squared divided by yz to the third. Now notice there's division here between x squared and yz to the third. So when two things are being divided, we can split it into two logs with the operation of subtraction. That's the quotient rule. So this becomes log base a of x squared minus log base a of yz cubed. Now we can take this further a couple different ways. One is that notice that y and z to the third are being multiplied together, so we can split up the y and the z further using our product rule. So let's leave our first term alone. And what's being multiplied? Oops. Our y and z to the third. Oops, I don't know what happened here. So let's split up that product using addition. So this becomes log base a of y plus log base a of z to the third. Notice I'm putting that in parentheses because that whole thing is being subtracted here. Okay? Now we have exponents. 2 and 3 are exponents, and the power rule says we can bring those over to the front. So this becomes 2 log base a of x. And simultaneously, I'm going to take this minus sign and distribute it in. So minus log base a of y minus 2 log base a of z. So this example uses all three of our properties, right? We're using the quotient rule first because x squared and yz to the third are being divided. And we split up that quotient using subtraction. Then since y and z are being multiplied together, we can split that up into two logs with addition. That's our product rule. And then finally, since we have a squared and a third power, we can bring those over to the front using our power rule. All right, our next example is the natural log. This is supposed to be the square root of 3rs to the third. Now it's important to understand that the square root is the same as the 1/2 power. So this is 3r squared s to the 1/2 power. And now we can handle this one of two ways, and either one is fine. We can bring the 1/2 over to the front first using the power rule, or we can distribute the 1/2 to each expression. So let's do it both ways. One way is that we can bring the 1/2 over to the front. So we have 1/2 times the natural log of 3r squared s. Now keep in mind this 1/2 applies to everything that we're taking the natural log of. So now 3r squared and s are all being multiplied together. We can split that up with addition. That's the product rule. So because 1/2 natural log of 3 plus 1/2 natural log of r squared plus 1/2 natural log of s. So again, the 1/2 applies to all the pieces inside. Finally, this second power can get brought over to the front using the power rule. And if we multiply 2 and 1/2 together, that just leaves us with 1. So it's just 1 natural log of r plus 1/2 natural log of s. All right, alternatively, we can take our same expression and distribute the 1/2 power in first. So we can make that 3 to the 1/2. And here when we distribute, we multiply the squared and the 1/2 together, so r to the first, and then s to the 1/2. Now these pieces are being multiplied together, so like the previous method, we're going to split it up using addition. So ln 3 to the 1/2 plus ln r to the 1 plus natural log of s to the 1/2. And then our powers can be brought to the front. So 1/2 natural log of 3, bringing 1 to the front doesn't really change the value, and then 1/2 natural log of s. They're both equivalent. All right, our last couple of examples ask us to combine the expression as a single logarithm. So this time we are condensing. So let's take a look at these. Well, actually, let's go back for a moment. What you want to do is look for coefficients first. So here we have 1/2. The best thing to do is bring those up as powers in our first step. So this becomes log 12 plus log 7 to the 1/2 minus log 2. All right, so let's condense into a single logarithm. So it's going to be one big log. And we have to ask ourselves, what are we doing with our arguments? What are we doing with the 12, the 7 to the 1/2, and the 2? Well, the 12 and the 7.5 we're adding 2 logs to get the 12 and the 7.5. So because we're adding, we're going to use our product rule. So we're going to multiply 12 and 7 to the 1/2 power. And since we're subtracting the log 2, we're going to divide that argument too. So anything that's being divided goes in the denominator of your quotient. Anything that's being added goes in the numerator of your quotient. Now if we wanted to simplify this a little bit further, we could 12 divided by 2, and that makes 6 times 7 to the 1/2. If you wanted to make that even more simplified, you can write this as 6 square root of 7, because 1/2 power is the same thing as root 7. So this is your most condensed answer. All right, our second example is log base 5 of x squared minus 1 minus log base 5 of x minus 1. So when we see the subtraction of 2 logs, that tells us to use our quotient property. So we're going to take the quotient of x squared minus 1 and x minus 1. Now, you can leave your answer like this, but if you remember your factoring, x squared minus 1 can be factored into x minus 1 and x plus 1. And here our denominator is still x minus 1. And the great thing about that is we can cancel out the x minus 1s. So it becomes log base 5 of x plus 1. And the main application of the property is turning it into a quotient. But again, if you remember your factoring, you can simplify some more. All right, so this is standard 6.7. This is expanding and condensing using properties of our logs.